All right, so next section is section 3.4 and 3.5, sine and cosine function graphs. So here we're just focusing on sine and cosine function graphs and sinusoidal functions, basically transforming them. Okay. So far in Unit 3, we've learned how to define sine and cosine values for angles in standard position, how to measure angles in radians, right, to go from degrees to radians, and how to use the unit circle to evaluate sine and cosine functions. Now we will put all of these ideas together and discover that they can help us develop and understand how to represent sine and cosine graphically. So let's start by considering the function sine of theta. Since we know the angle measures in standard position are periodic, right? That means they will be repeated. We can expect f of theta to also be periodic, so the function itself. Also, since theta is our input value, we will use the horizontal axis for our angle measure. So the horizontal axis is basically going to be our theta, and the vertical axis for our output. So the vertical axis is the y. That's going to be our output. Now on a unit circle, right? On a unit circle, the greatest point from the center is 1. So you'll notice that the highest and the lowest point will be 1 and -1 because that's our radius. Now, one thing we have to remember that sine of theta is equal to y over 1, our radius of 1 on our unit circle. So sine of theta is represented by the y value. So in this problem, we're basically going to be identifying just the y values. We're going to look at just the y's, okay, for sine. Now they didn't put here pi over 4, all of the quarters, because they did it in the last section for 3.3. So we're focusing here on just the sixths, the thirds, the halves of the unit circle, and the wholes, really. So according to this, sine of pi over 6, so pi over 6 is right here, and the sine of pi over 6 is 1/2. Sine of pi over 3 is square root of 3 over 2. Sine of pi over 2 is 1. Sine of 2 pi over 3 is square root of 3 over 2 again. Sine of 5 pi over 6 is 1/2. Sine of pi is 0. And then as we keep going, right, I'm just going to be plugging in. Sine of 7 pi over 6 is -1/2. 4 pi over 3 is negative square root of 3 over 2. Sine of 3 pi over 2 is -1. Looks like I forgot to highlight that. -1. Sine of 5 pi over 3 is negative square root of 3 over 2. Sine of 11 pi over 6 is -1/2. And then we come back to 0. Excuse me. So now we have our inputs and we have our outputs, and we can graph them. So at 0, right, sine of 0, even though we didn't really graph this, so when theta is 0, which is right here, our sine of 0 is going to be 1. So our graph is going to start up here. Pi over 6, we are going to be at 1/2. Pi over 3, we are at square root of 3 over 2. So not yet. Not yet Wow, I circled 0 and I said 1, didn't I? Sorry about that. Let me fix this. Okay. So sine of 0 is 0. At pi over 6, we are going to be at 1/2. At pi over 3, we are square root of 3 over 2, so it's not yet 1, but we're getting there. And then at pi over 2, we're at 1, and so on. I'm going to graph just the easy ones for now. So at pi, we are at 0. At 3 pi over 2, we're going to go down to -1. And then at 2 pi, we are at 0. So I don't need to graph every single one of those points in order to see that the function does one of these. And of course, because it's periodic, it does keep going in both directions. So a few things about sine function that we have to remember. Okay, is this idea of midline. Midline on sine of theta is basically going to be halfway between the highest and the lowest point. So the way that we solve for the midline is, which is in this case right here, the formula for the midline is the highest minus the plus the lowest divided by 2. And we'll talk about that in a little foldable in class. But it's the midline is halfway between the maximum and the minimum values, which basically just relates to max. To figure out the midline, it's going to be max plus the min, but then divide that by 2. All right, so next up, we're going to talk about the amplitude. So the amplitude is the distance. The amplitude is the distance from the midline to the maximum or the minimum. So in this case, here's the maximum, here's the midline. That is our amplitude. So our amplitude is going to be 1 in this case. Okay. Next up is frequency. So period. Period basically says, when does this function start repeating? So for sine of theta, when you haven't changed anything, the period is always going to be 2 pi. So I'm going to go over 2 pi before I start copying and pasting this function. So the period is going to be 2 pi when it's sine of theta. Now, the way that we solve for period is a formula, and it's always going to be 2 pi divided by b, which we will talk about in the next section what b is. Next up is the frequency. So the frequency is the reciprocal of the period. So whatever our period is for that function, we're just going to take the reciprocal of it. So 1 over 2 pi. It's the idea of frequency. I'm not going to lie, it hardly comes up in this class. And I just want to make sure that I'm saying the definition correctly, but it's the number of occurrences of a repeating event. So how many times does it occur? Okay, So the formula is always going to be 1 over whatever your period is. And if you think about sine waves and radio waves, you know that high-pitched frequencies where it oscillates a lot closer together, that is going to be a higher sound compared to lower frequencies where it's a lot farther apart. Okay, so with a frequency, we're going to think about it as how many number of oscillations per second. Okay, so frequency, you're always going to be thinking about it as per second. And in this case, the frequency is 1 over 2 pi per second, which is a lot, right? Because remember, pi represents 3.14. So this is about 1/6. Every 1/6 of a second, this thing is going up. It's oscillating up and down, okay? All right, next up, we're going to be talking about cosine. So it's the same thing, except for cosine, we are going to be focusing in on the x values. The x values of that point, right? So again, I'm not going to graph every single point, but we know that cosine of pi over 6 is going to be the square root of 3 over 2. Cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. So that means what is the x value for pi over 2? For 2 pi over 3 is -1/2. And so on. I'll let you guys fill in the majority of it. I'm going to fill in a few of them along the way. We got 0, we got the half, and then we got 1 again. So once we are graphing these points, the inputs and the outputs for cosine, right? We know that at 0, we're starting at 1. Again, I'm not going to graph all of them, right? At pi over 6, we are going to be, well, let's graph pi over 3 first. So at pi over 3, we are at 1/2. At pi over 6, we are square root of 3 over 2, which is about 1.7 something, right? So it's kind of right there. Sorry, it's about 0.7, not 1.7. Then at pi over 2, we go to 0. And I'm going to graph again. I'm just going to focus in on some of them and not all of them. That's going to be -1/2. At pi, we are at -1. At 4 pi over 3, we are coming back to -1/2. At 3 pi over 2, we are at 0. Then half, and then 1. So cosine looks like a cup. Not the best graph I've ever made, but right? And because it is periodic, that means it keeps going forever and ever. So again, as we go through this, the midline for just cosine, right? It occurs at y equals 0. Unless there's a shift up and down, it occurs at y equals 0. The amplitude, which is from the lowest point to the midline, or half of the max minus the min, is going to be 1. The period, which is asking basically when is this thing repeating itself, okay? It starts repeating at 2 pi. So every 2 pi, I can copy and paste this function. If I picked up this little swing set that you see here and pasted it right next to it, it'll be the same. And then the frequency is always going to be the reciprocal of the period, or 1 over whatever the period is, okay? So If it's just cosine of theta, the period is 2 pi and the frequency is 1 over 2 pi. And remember, just like sine, cosine oscillates between concave down and concave up. So here it's concave down. At the midline, it starts to become concave up. At the midline, concave down. All right. So a lot of information all at one time, right? Why do they call them sinusoidal functions? A sinusoidal function is any function that involves additive or multiplicative transformations of sine. The sine and cosine functions are both sinusoidal functions because if you graph just cosine of theta and then graphed sine of theta plus square root of 2, you actually do get the same exact function. So you can take out a calculator and test that out. Okay, so sinusoidal functions, we call them sinusoidal when there is an additive or a multiplicative transformation, either up, down, left, right, or a vertical stretch, horizontal, or shrink. Okay, so let's look at these functions, these little examples. So in this example, we have 2 periods of a sinusoidal function. And the reason I know it's 2 periods is because if you look at this point right here is 1 period. Because if you pick up this little section that I just highlighted and put it down again, you get the exact same points. So 2 periods are shown. So the question is, what is the period of this specific function? Well, the period is actually pi. So one period, I don't know why it's not letting me write, 1 period is pi. So once we know the period, we know that the frequency is 1 over pi. Now to figure out the midline, it's basically the max So this is the max. I don't know why my pen is acting up. So max, and this is the minimum value of the point which occurs at 0. And the midline is going to be the max plus the min divided by 2. So the midline is y equals 6 plus 0 divided by 2, and that happens at 3. So here's the midline. I'm going to draw it. That's the midline. And then the amplitude, how do you find the amplitude? It is actually the max minus the min divided by 2. So that's going to be 6. So A is going to be 6 minus 0 divided by 2. And that is 3. And that is correct. From the midline to the max and from the midline to the min, the distance is 3. Okay, very easy problem. So several periods of a sinusoidal function as shown. Let's find the period. So there's different ways of doing it. You can kind of start anywhere you really want. It's easiest to start right at, I don't know why my pen is acting up. I know it's charged, so that can't be it. is weird. Okay. So when you can fast forward that part, I guess, right? So when we start, we are at 0, 3. That is the maximum. And at what point does this graph start repeating itself? Well, here I'm at the min, and then I'm back at the max, right? And then it just starts repeating. So the period is from 0 to pi over 2. And the distance from 0 to pi over 2 is, well, pi over 2. And then the frequency is going to be 1 over that pi over 2, which is the same thing as saying 2 pi. Okay, so that means every second, this thing is oscillating from 0 to 2 pi. All right, now how do we figure out the midline? Well, it's the max, right, which is at 3, plus the min, which is at -1, divided by 2. So 3 minus 1 is 2, divided by 2 is 1. So the midline is occurring right there. And once you figure out the midline, you know the amplitude. So the amplitude, just by looking at the graph, you know that it's 2, right? But if you don't have a graph, but you know your max and your min, it's basically going to be just your max minus your min divided by 2. So your amplitude is going to be 3 plus 1 divided by 2, and that's 2. And that's what we saw here. So a good example of this problem is the next one. Well, here, the sinusoidal function, you don't have a graph. It has a maximum point at 8. The first minimum after reaching this maximum value occurs at -2. So the first time that it touches the minimum is at -2. 3 pi -2. So right now they basically are giving us this information. So if this is pi, 2 pi, 3 pi, so at pi we are at 8, and then at 3 pi we are at -2. So this is the max, this is the min, right? I don't know if this is a concave up or concave down, it really doesn't matter. Find all of the information, okay? So we want to find all the information. Now I know to figure out period, if this is starting at the max, the only way I can figure out the max is I want to ask myself, when is the next time it actually goes back up to the max, right? But all I have is 3 pi and pi. Now I know that 3 pi minus pi is 2 pi. So it takes 2 pi to reach half of a period. 2 pi for half of a period. To go from max to min is half of a period. So I need another 2 pi to reach the max again to complete my period. So either you can see that it's 2 pi and then add another 2 pi. So 2 pi plus 2 pi. So one period is going to be 4 pi. Or you could have just saw that, okay, this guy takes 2 pi to get here, so another 2 pi and add it up. But using the words max to min, that's always going to be your half a pi. Okay, max to the second time it's at a max, that's going to be your whole entire period. All right, frequency is going to be 1 over 4 pi. That one's very easy. That means in 1 second it goes 1 over 4 pi. The midline is going to be the max. It's at y equals the max plus the min divided by 2. So 8 minus 2 is 6 divided by 2. That's at 3. That's our midline. And then the amplitude is going to be the max, okay, minus the min divided by 2. So it's going to be at 5. So that means the distance from the midline to the max or from the midline to the min is 5. And that makes sense. The midline's at 3, our max is at 8. That looks like about a distance of 5. All right, the last part is we're revisiting this FRQ. So I want you guys to kind of do part A, right? Because that we've already done this exact same problem for part A. And then try to figure out what is the period, frequency, amplitude, and midline for that graph. And in order to do that, you need to figure out what are these points? What do they represent? Okay, and that's it. Enjoy.